actually. So it's not, we do not take the, I mean, for CGE modeling, we do not take the inverse per se. Perhaps, I mean, when we resolve the system, perhaps GUMPS will do it. But the question, I don't remember who was asking this question, perhaps Rafa or Ibrahim, I don't remember. But there is another technique where we want to calculate the multiplier. When you want to run a multiplier model, a small multiplier model, and you run the Leontief relationship, where we have to take the inverse of the input-output table, then we have to introduce all the characteristics associated to the inverting matrices, singular versus non-singular matrices, and all that. But that's just a very small application for multiplier models using the Leontief inverse or the Leontief matrix. Okay, but for CGE modeling, it's much wider than that, because for CGE modeling, we do not just look at the input-output table, which is part of the social accounting matrix, but we look at the whole social accounting matrix that includes other accounts than the input-output table. So is that clear? So his question was specifically related to the multiplier model where we use the Leontief matrix, but not CGE models.
Okay, thank you.
Ramil Azhari, you have a question?
Yes, good evening, Chahir and everyone. I want to thank you for your professional presentation last session, but actually I have two questions.
Sure, thank you.
First, actually, I wonder if we can have the material, including the record after the end of each session or not. Second, are there any restrictions related to SAM's division? As you mentioned, that sometimes in SAM, we can divide some sectors to its main subsectors.
So on the first question, yes, you will get all the material by email, and the recordings will be available on the website of ERF. But they will be available on the website after we finish the workshop. As far as I understand, perhaps Namis can confirm that, or Ramash can confirm that, because I think we do some editing just to make them clearer when they are uploaded on the ERF website. So probably they will be available late next week or something like that. I am correct, Ramaj, or?
Yes, Chahir. The materials and the recordings will be available on our website right after the training.
Great, thank you. And then on your second question, I mean, my understanding of your question is two things. So first, do we have any restrictions when we divide the matrix? You mean divide the matrix when we create some variable from the matrix, or disaggregating the matrix into different subcomponents?
Yes, disaggregating the matrix to the subcomponents of each sector of or some sectors that we have. As you mentioned, that
yes,
can divide the agriculture sector to many subsectors, where we can use the manufacturing sector as a whole or as a gross sector.
Okay, so actually, this depends mainly on two things. First, it depends on, as I said, on your research question, whether you want some details in some sectors compared to other sectors, or you want to aggregate other sectors that are not as important as your sectors of interest. So the really, I mean, the main determinant in this case will be your research question. That's first. Second, it will depend on data availability, because if you're going to split a sector into, let's say, 10 subsectors, then you have to do this in everywhere when the sector appears in the matrix, and this is data demanding. So that's why you have to check that you're able to disaggregate, for instance, the input-output table with the same level of details if you need such a disaggregation to answer your question. So the first criteria is your research question, and the second criteria is your data availability. If both are there, then you can you can disaggregate as much as you can in the social accounting matrix.
Okay, thank you.
Other questions? Okay, so if we don't have more questions on the previous part, then today we have 2 sessions, and they are very applied sessions. But for the first session, I'll just give you some elements related to the GUMS language, just to get familiar with the code, the language, the code that we use, or the language of GUMS that we use. That's 1. And 2, I will give you the first model that we write today in GUMS. Okay, so please make sure after the break that you have your GUMS version that is working, because it will be mainly hands-on training on the code that I will present. Okay, so the first part, as I said, will mainly look at the code of GUMS. So I will give you an introduction to GUMS, just in terms of the intuition, the way we write the different variables, and so on. So the objective of this session is to give you what are the main rules that we have to bear in mind when we start using GUMS. And GUMS stands for the General Algebraic Modeling System. And it's a software that is in general used for matrix calculations. It's a bit similar to MATLAB. The language perhaps might be slightly similar to R in some cases, but in general it deals with optimization. So by optimization, I mean that we're trying to maximize some functions subject to other functions. And in general, we have 3 stages. So the first stage deals with the input that we need or that we insert in GUMS. Okay. Second, the model that we want to run, which is our CGE model. And the third stage is the results that we get. And I just want to compare between GUMS and Stata because they are very similar. And so then for GUMS, the data that we need is the social accounting matrix, and in general it can be inserted in GUMS or imported from Excel, either or. Second, but this in Stata, it's more on, I mean, we import the data under a DTA format, so we know that the files of GUMS are .dta. Then for the model, we write the model in Stata in a do file, which is the .do, the do files that we have. For GUMS, in general, the files, the equivalent of the do file is .gms. And we will see that this .gms file is the main file where we're going to write everything, the variables, the codes, the parameters, the equations, the solutions, everything in this GMS file. Then when we get the results, we have in Stata the log file that is generated once we have the results. And in GUMS, we have the listing or the GDX. So the listing is the file that is generated by GUMS that help us make sure that the model is working. And for the GDX file, it is the file that is generated and includes different simulations. Okay, so that's mainly the comparison between Stata and GUMS. An important thing is that in Stata, if you remember, we have the project directory when we write CD in order to have like the folder where everything will be generated, new results, log files, Excel sheets, everything. And the equivalent of that in GUMS is the GPR, which is the project file. Okay, and we'll see that when we start working on the model. So the basic components of a GUMS model includes the following. So we have first in the inputs, we have to declare 3 things. So we have to declare the sets. And by sets, I mean whether I have, for instance, a set that includes the different types of households, urban households, rural households, or for instance, skilled labor, unskilled labor, males versus females. So all the sets are included in this first part. Then the second part, in the inputs, we have to declare and assign the parameters, meaning that we have to tell GUMS that the parameters of the model are, for instance, alpha, beta, gamma, and so on. And then we have also to include the data that comes from the social accounting matrix. So those are the three inputs that we have. Then, in order to run the model, we need first to declare the variables, then to declare the equations, then to write the mathematical statement of the model, and to ask GUMS in some cases to display this statement, meaning that to display the outcome that has been generated by GUMS. And finally, we get the outputs. And the outputs of GUMS include several things. It includes, most importantly, the status report, meaning that what is the status of the model, how many variables do we have, how many exogenous, how many endogenous variables do we have, how many years are included, and so on. That's one. Two, we get also the equation listings, which means that we're going to have for each equation that is solved in GUMS, whether this equation has been correctly solved or not. In other words, whether my left-hand side is equal to my right-hand side or not. So as I said, in general, for the structure of the GUMS model, we start with the SAM, the sets, the parameters, and the data assignment. So that's the SAM that we have. It's a very simple SAM of Egypt of 2010 and 2011. So it's the aggregated version. And this aggregated version is similar to the one I presented yesterday. And as you can see, we have 9 rows and 9 columns for the same accounts. The totals are identical for different rows and different columns. And this matrix has been generated by IFPRI for a project related to subsidies and removing subsidies in Egypt. So that's the data that we have here, I mean in the SAM, and that can be imported into GUMS. In order to, that's regarding the data. Regarding the sets, in general, you will see that in GUMS, there are some commands, when we write these commands, they become blue. So they become blue, which means that they are implemented in GUMS. So for instance, when I write the word set or sets, it becomes blue, as you can see here. And here, for instance, I have a set for activities. So I have 3 activities: manufacturing, agriculture, and service. Or I have 3 factors of production: labor, capital, and land, and so on. So I can write them this way, or I can write them as you can see in the lower part of the slide, where A, which is the set of activities that include M, which is the manufacturing, and Agri, which is agriculture. Okay? So it's important to bear in mind that that the SAM is that those sets are important, because in general they will save a lot of time and effort, given the fact that I can declare a certain equation over different variables. There is a question, just a second. So can we use a SAM established for more than 1 year? No, the SAM represents economic flows for 1 year, but here for just 1 year. But here for the Egyptian case, it's written 2010-11, because in Egypt, we work with the fiscal year that starts in July of the year before and that ends in June the year after. So in other words, the SAM covers the period between July 2010 and June 2011. That's why we call it the SAM of 2010-2011. But it's 1 year.
Do you hear me? Do you hear me right now?
Now, yes.
Okay, Zahir, sorry. maybe it's an early question, but I'm just wondering if we have a shock or like, let's say Egyptian government levy on a new tax. So I would like to see the effect of this tax on the economy. And you know, I mean, when we apply a policy, a monetary policy, or sorry, we don't see the effect of monetary policies here, but a fiscal policy, when I want to see the effect of a fiscal policy, I think I should use a data covering more than 1 year, right? Because
No, just 1 year.
but how a tax can affect an economy just in the year it's applied or levied on?
No,
Because-
that's another thing, because in this case, we're going to
sorry,
have
because
dynamic
policies
model.
should have long run effect, right?
Yes, but here in this case, it will be a dynamic model, meaning that I will start with the same SAM that I have for my base year, but the model itself will have a time dimension, meaning that the model will be resolved for, let's say, if we assume that we're in 2020, then the model will be solved for 2021, 2022, 2023 until 2030 or 2050. I mean, it depends on my time horizon. But
I will use the data just
yes,
for
just a second. But
yeah.
but in any case, I use the data just for 1 year, which is my base year, and then the rest, or the period over which the simulation is solved, this depends on the nature of the model. If it's dynamic, I can resolve the model for several years. If it's static, then it will be resolved for just 1 year. Is that clear?
So I can use the data for just for 2010, and I can see the effect of this tax on the, like, let's say the economy in 2020.
Yes.
So it will generate data for the other years, the GEMS itself?
No, I will not. I'm not generating data. I'm solving the model for different years.
Okay.
Based
Like kind
on,
of forecasting maybe.
Based on the base year. So it's just one base year, and given the base year that I have and given the model that I have, I will solve either the model. I will solve the model either for 1 year, and in this case I'm comparing the before and after shock, and that's it. Or I will compare the before shock, and after the shock I will solve the model for 10, 20, 30 years, as long as I wish. But this depends on the model itself, not on the data of my base year.
Okay, thank you. It's clear.
Thank you. So another question, is it possible to import defined sectors from a file, e.g. list of sectors from a CSV file? For the sets, we have to declare them in GUMS. But for the data itself, yes, we can import them from XLS or CSV. The data, I mean, the data included in the SAM. But for the sets, we have to declare them in the model itself, in GUMS code, I mean. Okay. Then after we declare the sets, we have to declare the parameters. And the parameters, in general, they are exogenous, because their values, they do not change in the model, given that they are parameters. And in general, we define the values of the parameter from the base year. And we will see today that we have two options for the parameters. Either we impose their values from the literature, or we calibrate their values from the social accounting matrix. So those are the two options that we have in order to run, in order to declare and assign values for the parameters. So either we calibrate them from the SAM, and we will see how the calibration works, or we take their values from the literature and impose these values in an exogenous way. For the parameters in general, if we don't declare a specific value, then by definition or by default, it will be 0. So that's why we have to bear this in mind, because if we don't declare a specific value for the parameter, the model might not be solved in this case. This is just an example of data entry in a SAM. So as you can see here, we have I mean, in the GUMS code, a table called SAM that has 2 dimensions, where we have all the accounts, as you can see here: labor, capital, salaries, capital remuneration, and so on and so forth. Perhaps I will keep this for now because we will see more details on the code when we start working on GUMS, but I just want to give you the general rules that we need before working on the code. That's to answer the question of Salahuddin Summan, how we can import data from Excel. So in general, the syntax, if you want to recall some data from Excel files, so we have the $sign call mean that we import the data, and then we write the name of the file. In this case, it is stg1_data.xls, and we import the data in GUMS. Okay. So some general rules regarding, and those rules are really important because we will use all of them in the analysis. So a rule, I mean a golden rule for GUMS, we always have to declare first and then to use. What does this mean? It means that I have, for instance, to declare first what are the parameters that I have in my model. That's one. And then use those parameters in equations. So in other words, I cannot use the parameter in the model before declaring them. That's rule number 1. Rule number 2, in general, at the end of every line in GUMS code, we have to add a semicolon, and those semicolons means that the command is over, because if we don't end the line with a semicolon, this means that GUMS will continue reading in the next line. So to declare that the line has ended, we have to add a semicolon. A third important point, and that we already discussed, that we have to distinguish between volumes and values. Values that include the price and volumes that shows just the quantities. In general, GUMS is not like Stata. GUMS is not case sensitive. I mean, if I include capital letters or small letters, GUMS will not be able to distinguish them. But by convention, we use small letters for parameters and the capital letters for variables, just to make the notation more reader friendly. Okay. And in general, what are the operators that we need in GUMS? So we have the star here that is used for multiplication, the minus for subtraction, the plus for addition, then the slash for division, and the 2 stars for exponential. Okay. Then we use the equal sign to say that we have an equality in any kind of operation. And then we have some operators that are used when we want to run the equation over several elements, like sum, like prod. So the summation, we use the sum over a certain number of components. We use the product for the production, or the product of different sets. Again, if for instance I want to do the summation over 10 sectors, in this case I will write sum over, let's say, sector I, and then do the summation for exports, for instance. Abs means absolute value, x means the exponential value, log is the logarithm, and max is the maximum, and min is the minimum. So it's very intuitive. The most important thing is that we have to have at the end of each line the semicolon, just to declare that the line is over. Okay. Just as a way of exercising, okay, here we have two sets, right? We have the sets of the labor factors and the set of the subset of labor factors and the set of factors, meaning that this one is part of the other one. So here I have labor factors, skilled labor and unskilled labor, slash to tell GUMS that's our set. And then we have F factors that include labor capital and land. As you can see here, what is missing is the semicolon at the end of the second line. Why? Because we have to declare to GUMS that there is that the command is over. If we don't do that, GUMS will not be able to really understand that the command is complete. Is that clear? Any questions? Anything that's not clear? Any questions? Okay. So moving to the second part where we have the variables, the equation, the calibration, and the model. Again, I will give you the general rules and then we start with, we practice this when we start working on our model. In general, for the variables declaration, we have to write the word variable. And as you can see, when we write it, it will become blue because it's an implemented code in GUMS. We have several types of variables. We have variables that are free, meaning that they don't have an upper limit or a lower limit, and that's why they go from negative infinity to plus infinity. We have some variables that are positive or non-negative. If they are positive or non-negative, then they go from 0 to plus infinity. We have negative variables that go from negative infinity to 0. Okay, and then we have binary variables that are either 0 or 1, and we have integer variables that go from 0 to infinity. So those are the different types of variables that we have, and we will see that it's important because we will see in some cases some variables will be constrained between 0 and 1. Some variables have to be non-negative. Some variables can be negative and positive. But for instance, in our quantities, if we talk about consumption, government consumption, exports, imports, they cannot be negative because I cannot have negative exports. I can have negative net exports, but I cannot have negative exports. So that's why it will be in this case positive or non-negative, and so on. For the equations, that's the rule that we have. So again, I remind you that the golden rule in GUMS is that we have to declare first and then use. So we declare the equation, that here I have two equations, utility and budget constraint. So I declare the utility objective function, the budget constraint, I declare the name of each one of them, okay? And then I assign a value for each equation, okay? So the utility here, as you can see, it's utility. We write 2 points, 2 dots here, right? To tell GUMS that what comes after is the value of this equation. So U, which is the name of my utility variable, equal E. E stands for equality of the equation, okay? And then I tell GUMS that the value of the mathematical equation is the production over C of Q to the power beta. So in other words, this utility function looks like that. So U is equal to the product over C of QC, right, to the power beta C. So that's how this equation look like. When I want to write it in GUMS, I have to write it this way. And clearly, as you can see at the end of the line, I have to add a semicolon to tell GUMS that the command is over. Is this clear? Any questions? Any questions? Anything that's not clear? And then we do the same with the budget constraint. So the syntax for defining equations, as I said, the name is stated followed by 2 dots, as I said. The equation is defined ending with a semicolon to tell GUMS that it has ended. And then the E between the left-hand side and the right-hand side shows the equality. If I want to use greater than or less than, I will replace the E with G or L. And then it's important to bear in mind that in general, each equation will be defined only once because I declare the equation and then I will assign to this equation a mathematical value. But an important thing is that the variables, that I have in my model can be used in several equations, but the declaration of the equation is done just once, okay? The order of declaring the equation does not matter. I can write first the utility function and then the budget constraint, and I write the budget constraint and then the utility function, because at the end of the day, GUMS is going to resolve all this simultaneously, okay? The calibration, I will leave it for now because we're going to talk about that later. The next stage is the variable initialization, and for the initialization, it means that which variables will be declared as exogenous and which variables will be declared as endogenous. Why? Because we need to have here in order to solve the model. So in order to solve the model, we need an equal number for unknowns and equations, because if we have more unknowns than the number of equations, this means that we have no solution because the model is under identified. If we have more equations than unknowns, then the model is over identified and we don't have a unique solution, we have different solutions. So in order to have a unique solution of the model, we need an equal number of equations and unknown variables, right? And that's why unknown variables will have to be endogenous. And extra variables, in order to make this equality between the number of equations and the number of endogenous variables, we will have to exogenize the other variables. So for endogenous variables, in order to declare that a variable is endogenous in stata, we add the suffix .l, which stands for level, okay? I will come back to this later when we work on the model. And then if I want to assume that a variable is exogenous, then I add .fx, okay? Which shows that the variable is fixed and does not change, and it will remain exogenous in the model, okay? That's for the variable, the step that we call initialization. Other than that, the final point, and that's really important, for the closure. The closure is a very important concept in CGE modeling. Why? Because the closure in general shows what are the assumptions that we adopt in order to solve the model. And the choice of the closure highly affects my results. Meaning that if I assume that the share of fiscal deficit to GDP is constant, I will have some results. But if I assume that the share of current account to GDP is constant, I will have different results. If I assume that my exchange rate is the numeraire, I will have some results. And if I assume that the producer price index is the numeraire, I will have other results. So this means that whenever I choose, the closure, it has to be motivated. And this motivation comes from three things. First, it comes from the characteristics of the economy itself, whether my economy in reality has a constant share of current account to GDP or not. What does the literature say on this topic? Because in some topics, we have some well-established closures that have to be adopted. And what is my research question? Because, for instance, if in my research question, I want to have the exchange rate as an endogenous variable that will change, in this case, I cannot assume that it is an exogenous variable, because I want the exchange rate to change and to see how the exchange rate will react due to any policy change. So that's why, to a large extent, my research question will affect the choice of my closure. So is the concept of closure clear? Because this is very important in the CGE literature. So any questions on the closure? If you have any, please unmute yourself and speak, just to have some interaction in the session.
Yes, please.
Anything
I have a question.
Yes.
How can we express our closure of our model mathematically? If you have any example, for example.
Yes, I will show you in a few seconds when we start the GAMS code.
Okay, thank you.
Other questions? Everything is fine. Okay. So then we solve the model. When we ask GAMS to solve the model, so I will show you in the code where we have to press in order to solve the model. And in general, GAMS will solve the model, all the model at the same time, simultaneously, as I said in the beginning. And that's why, in general, we ask GAMS, as you can see here at the end of the slide, we write the word model, that becomes blue. utilmax is the name of the model I'm solving. And here we have /all/, which means that I'm asking GAMS to resolve all the equation simultaneously, okay? And then when I solve the model, I have to choose what we call a solver. What is the concept? As you can see here, solve utilmax. Utilmax is the name of the model. By maximizing U, that's what I'm asking GAMS to do using NLP. NLP, it's nonlinear programming. LP, linear programming. CNS, constrained nonlinear system. So all these abbreviations, CNS, LP, all these abbreviations, they stand for the solver that we choose in order to resolve the model. What does a solver mean? So it will be the procedure that GAMS adopts, the mathematical procedure that GAMS adopts in order to find the unique solution of the model. So the solution can be, this procedure can be either a linear programming or nonlinear programming if I have nonlinear functions, or can be a constrained nonlinear system if I'm imposing some constraints on my system, and so on. So we have a lot of solvers. I will not go into the details of the choice of solvers. We'll just adopt a simple solver. And in general, in most of the cases, we adopt CGE models. We adopt the CNS, the constrained nonlinear system, that help us finding the solution subject to the constraints that we have in our model, meaning that I'm maximizing, for instance, the utility subject to the budget constraint. I'm maximizing the profit subject to the production constraint, and so on. Okay. Any questions? Okay.
Chahir, I have a question.
Yes.
Can you go back, please, one slide back?
Yes.
Yeah, it's called LP procedure. So is there a criteria choosing any LP procedure? Which one we have to choose?
Yes, actually, it depends on what I'm doing in terms of, again, in terms of the structure of the model and the research question. But in most of the cases, we solve CGE models either using the CNS, the constrained nonlinear system, or using the nonlinear programming if I have a lot of nonlinear equations. So those are the most frequently used solvers in the CGE literature.
So is there any difference between these two solvers, between NLP and CNS, or I can use any of them?
No, there are some differences between both, but I think this will be a very technical discussion. Perhaps we can have this discussion later on a bilateral basis, because I don't want to spend a lot of time on the solvers, and because in any case we'll not be able to cover all the technical details of the solvers. So perhaps we can have this discussion later on the different types of solvers.
So I'm just wondering, sorry, I will not extend the discussion. I'm just wondering, for instance, if I use the CNS, maybe, I mean, it can be not appropriate for my case, right? For the model I'm establishing. So maybe it will be the wrong LP procedure. Is
not wrong, but I mean, you might not be able to converge, and if you might not be able to converge, then you will have to try the nonlinear programming, because in this case, the solver of the constrained nonlinear system is not able to converge, and as long as it's not able to converge, then it's not the correct solver. So you have to choose
I will understand. I will understand thanks to convergence if I'm using the correct LP procedure or not.
If it converges, then in this case it's correct, but it has also to be motivated through the research question itself.
Okay, thank you.
Then we execute the model. In general we press on this red arrow in order to run the model. So just to have some practice here. So we assume that we have this equation, W multiplied by LS plus R multiplied by KS, which is equal to income, semicolon. So what is missing here? The dot. If you remember, we said that we need 2 dots after the income, and in this case, GUMS will not be able to run the model. That's the first error. The second error is that, as I said, before assigning a mathematical value, we have to declare the equation first. So that's why before assigning a value to income, we have to declare that there is an income equation. So to recap what we have done, the first step is to declare and define the sets, the parameters, the equations and variables, and then we do the calibration, and I will explain the calibration now. We choose the closure, and we explain what does the meaning, what is the meaning of closure. Then we have to reproduce the data through my model, and that's what that was what we called 2 days ago replicating the data. And then we produce the benchmark scenario, we introduce the simulation, and then we do the comparative statics before and after the simulation. Okay, this means that at the end we will get the output, and the output will include all these things. It will include 6 main things. It will include the Ecoprint, and I will explain quickly what is the meaning of each item that we get when we run on execute. We get also the equation listing, the columns listing, the model statistics, the solve summary, and the results. So what is the Ecoprint? Ecoprint it's just a reproduction of the initial model I wrote in GUMS, where he will show me, because at the end of the day, what GUMS does, for instance, if I write, just to give you an example, if I write y that is equal to c, sorry. So I write c plus I plus g plus x, or plus net exports. Okay. So what GUMS will do in order to find a solution, he will write c minus y minus c minus I minus g minus nx that is equal to 0. Okay. If this relationship is not equal to 0, this means that I have a disequilibrium somewhere, and there is a flow in the model, an outflow in the model that is not taken into consideration. So that's why we have to make sure that the difference between the left-hand side and the right-hand side is always equal to 0 or almost 0. Almost 0 means that it's for instance 5 multiplied by 10 to the power negative 13, for instance. So it's 0.13 zeros and then 5. So it has to be very low. So that's the idea of the Ecoprint. In other words, it reproduces the model where I have the difference between the left-hand side and the right-hand side variables that will be equal to 0. And then the second part, we have the equation listing, where, as you can see here, I was just talking about for each equation, we're going to equate the left-hand side minus the right-hand side that must be equal to 0. And that's why GUMS is writing here LHS equal to 0. LHS means left-hand side. So the when the left-hand side is equal to 0, this means that I have an equilibrium between the left-hand side and the right-hand side. Ibrahim, yes?
Please, I have a question about the previous slide.
Yes.
What is the benefit of Ecobrand reporting? What insight that I can get from it?
It's automatically reproduced by GUMS in order to make sure that I mean, if I want to have a comprehensive file that includes first my model, second the solution of the model, third the summary of the model, so everything will be in one document if I want, for instance, to print that. But it's just for reference, not for solving the model, in other words.
Okay.
So we have the equation listing here. After the equation listing, we have the model statistics. So here, GUMS will tell us the number of equations that we have. So the block of equations, the block of variables, how many single variables do we have? How many single equations do we have? How many free variables do we have? How many in general, the number of endogenous variable must be equal to the number of equations that we have. So that's why the free variables here, meaning non-exogenous variables or endogenous variables, is equal to 58. So if I have 58 endogenous variable or 58 free variables, I must have 58 equations, and that's what we see here. So that's why this model can be solved in this case. In this case, we call it a squared model. Okay, and finally we have the solve summary, where the model, where as I was just saying, that the model was using the constrained nonlinear system here in order to solve the model, and we get the completion of the model. Then in the listing, for each equation and each variable, GUMS will determine the lower and the upper bound level of each variable. So for instance, for all these variables, we have the level that we obtain here, and the lower and the upper values are from negative infinity to infinity because they are continuous variables. In some cases, we have errors, and the errors can be divided into two types of errors. Either syntax, okay, and the syntax errors are very easily identified because GUMS will generate a red line that will guide me to the location of the error. And in general, these errors are very easily rectified. But more serious errors are related to either calibration errors or errors from the SAM or errors in the model itself. So that's why it's important to bear in mind that most of the syntax errors will be quickly rectified, but we might spend a lot of time on solving the errors related to the calibration, the model, the data, or for instance, that we declared some variables that are in quantities and they have to be declared in values and so on. Okay. I'm listing in the slides, I will send you some common causes of compilation errors, but I will keep this for now, will not present it because we'll see this when we start solving our own models. It will be more useful to you because now you will not be really able to grasp the idea of the errors unless you face the errors yourselves. Okay. Finally, we have some additional options, and that's just to make the file more cosmetic. So we can add a title, we can add a subtitle. If I'm working on a paper that I co-author, for instance, with Ibrahim, and I want to include some comments in the paper to let Ibrahim understand what I have done. So in this case, I can deactivate some line to add some lines in order to add a paragraph where I'm explaining to Ibrahim what I did in the simulations. So in order to deactivate some lines and to make them unreadable for GUMS, I can add in the beginning $on text. So GUMS will activate the text mode. And at the end, I will add $of text. The alternative option would be to add before each line a star. In this case, this line will be deactivated. So as you can see here, I'm adding a star before each line in order to make GUMS, read this line as a comment, not a command. So it's a comment for GUMS. It will not be executed while commands are executed. Okay. I will skip the example because we'll see it. Those are just some important resources that you might need for GUMS on the installation notes for Mac OS and the installation notes for Windows, and the demo version that is free. But then if you want to run full-fledged models, in this case, you will need to buy a license with GUMS. Those are the references, and that's it. Any questions on the GUMS code? Okay, if you don't have any questions on GUMS code, so in the last part of this session, I will present the first basic model that we will run together and that we will code right after the break. So we'll assume that we have a basic, we will call this model basic. So we assume that we have a Cobb-Douglas production function with two factors of production. One, good. It's a closed economy, so no exports and no imports. We have no savings, and if we have no savings, then we have no investment. And then we assume that we have an equilibrium for the labor market, the capital market, and the goods market. Those are the main assumptions that we have for our model. As you can see, it's a very simple model, but it's important to start with such a simple version to model it and to code all the details of this model in GUMS, and then we will add other layers to the model. Okay, so that's the mathematical statement of the model. The first equation is the Cobb-Douglas production equation, where we have production that is a function of A, which is the technology parameter, K, which is capital, L, which is labor, and then we have alpha and 1 minus alpha that represents the elasticity of capital and the elasticity of labor. Then we have wages multiplied by that we have here the wage multiplied by labor and rent multiplied by capital, and we will see how we can obtain these two equations. But these two equations, they show the labor demand and capital demand, and I will come back to this later. Then we have the fourth equation, where we have the total revenues of the economy, and the total revenues in the economy are simply wages multiplied by labor supply plus rent multiplied by capital supply. And here, factors of production, they will collect the revenues from the factors market in order to have one revenue that will be spent on consumption. Why on consumption? Because we don't have savings, because we don't have investments. So the revenue is equal to the consumption multiplied by the price. And then here we have the equilibrium block, where the production is equal to consumption, where labor demand is equal to labor supply, and where capital demand is equal to capital supply. So how we can calculate, or how we can derive these two equations from this one, it will be a simple maximization problem. So let's assume that we have this production function where I have y that is equal to alpha, sorry, k alpha, L1 minus alpha, okay? And if I maximize this, so, with respect to capital, for instance, then it will be partial y with respect to k, that will be alpha a k alpha minus 1 L1 minus alpha, right? So here I'm maximizing the production with respect to capital. When I maximize this in a perfect competition framework, what does this measure? What do you think? Any insights?
The elasticity with respect to K?
So it's no, I mean the whole term. What does it represent?
The partial changes of the production with respect to incrementation of partial capital.
And what does this measure concretely?
Marginal production of capital.
The marginal productivity of capital, exactly. So that's the marginal productivity of capital. And in a perfect competition framework, the marginal productivity of capital is equal to what? What do you think? So the marginal productivity of capital must be equal to the real rent. So the real rent is the rent over price, right? Because that's the marginal productivity of capital. So if I rearrange here all that, I can write it as following. So it will be alpha a k alpha L1 minus alpha divided by k, because I have here minus 1, which is equal to RP, right? So all this term, what does it represent? It represents the y. So I can write it this way. It will be alpha y divided by k, divided by k, which is equal to R over P. In other words, I can say that R multiplied by K is equal to alpha PY. And that's the relation that we have here. Right? So RK, which is equal to alpha PY. So why does this equation represent capital demand? Because the higher the production, the higher the demand for capital, right? And if I put the R here under the alpha and PY in the denominator, if R increases, K will decrease, right? So given the fact that R is the price of capital, if it increases, the demand for capital will decrease. So that's why the WL and RK represent the demand for factors of production. So if I do the marginal productivity of capital, and it will be equalized to the capital remuneration, I will get equation 3. And then in equation 2, we obtain this from the maximization of capital, sorry, from the maximization of the production with respect to labor. And then we're going to equalize this to the real wage. So I will do the partial derivation with respect to L, and then it will be equal to W over P, and we will get exactly the same thing that we had in the slide. So back to the model. So that's the model that we have. We have what we produce here, and then the demand for factors of production, labor and capital. Labor and capital, once they are used for production, households will be remunerated, and if they are remunerated, then we'll have a total revenue that will be spent on consumption, given that the revenue is a value and that consumption is quantity. So we have to multiply the consumption by the price in order to have the value of consumption, and that's what we have here. And the final block shows the equilibrium for goods, for labor and for capital. Any equations on the system that we have? Anything that's not clear? One final thing that we'll do, we want to list what are the parameters and what are the values that we have in the model. So how many equations do we have in this model?
Eight equations.
We have 8 equations, exactly. So we have 8 equations. So let's count the number of variables. So we're going to have a tour de table. Each person will list one variable. So we start with Ibrahim. What is the first variable?
Production.
Exactly. Y, which is production. Dalia.
Labor.
Sorry.
Wage labor. Wage labor.
Labor, exactly. Labor is the second variable.
WL, wage labor.
No, W is a variable and W is the wages and L is labor. So they are two different variables. Okay.
Okay.
Nadine.
Okay.
The next variable.
Capital.
Exactly. Alauddin, the next variable.
Rent.
The rent.
Sorry.
Perfect.
Yeah.
Thank you. Abdulillah. The next variable.
Price.
The price. Exactly. Nasseruddin.
Revenue.
The revenue. Perfect. Nisma. The next variable.
C.
Consumption. Perfect. Karim. What else?
I think it's labor. Labor
Sorry?
supply. It's labor.
Labor supply, exactly. That we call LS. And Salahuddin.
The total capital supply, KS.
Capital supply, exactly. So how many variables do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We have 10 variables here. Clearly alpha and A are parameters because that's the Solo's residual for the A, and alpha represents the elasticity of capital, and we'll show how to calibrate it. But we still have one variable that we have to add to the model. Why we have one variable that we have to add to the model? Because in general, we have to add a variable called Leon. What does this variable mean? It means that if in general, it's a variable that shows or that confirms that we have an equilibrium on different markets. So this variable is added to one of the equilibrium equations, any one of them, we can add it here, we can add it here, we can add it here, but it's added to only one equation, okay? If this variable is equal to 0, this means that I have an equilibrium model, a general equilibrium model. If it does not equal to 0, this means that the model does not converge and that there is an outflow, and consequently, I don't have a general equilibrium model. So all in all, how many variables do we have? We have 11 variables. And at the same time, how many equations do we have? 8 equations. So this means that the model is not identified because we have more endogenous variables than equations. So that's why we have to choose 3 equations. Sorry, we have to choose 3 variables that will become exogenous. Because if they are exogenous, this means that we're going to impose their values in an exogenous way. And in general, given the fact that we have a short-term model, so we can assume that labor supply and capital supply are exogenous. So how many endogenous variables do we have now? Sharafuddin, what do you think? How many endogenous variables do we have if we decide to exogenize labor supply and capital supply?
7.
No, count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right?
Yes.
So we have 9 endogenous variables. How many equations do we have?
We have 8 equations.
Still we have 8.
We have 8 equations. So this means that we still have an extra variables. And that's why we have to choose a numeraire for the economy, and the numeraire will be prices. So the price will be exogenous. In this case, I have 3 exogenous variables that are price, labor supply, and capital supply. And I have 8 endogenous variables, which are Leon, production, labor, wage, capital, rent, revenue, and consumption. So we have 8 endogenous variables with 8 equations, which means that the model is squared. And if it's squared, then I can solve it. Is this clear?
I have a question. So
Yes.
Leon variable will represent our equilibrium?
Yes. That's why it has to be equal to 0. Because if it's equal to 0, this means that I have an equilibrium on all markets.
So it's not variable.
No, it's
If
a
we-
variable.
If we define its value as 0.
Sorry?
If we defined its value as just a 0 or only 0, how it will variable? How its value will vary?
Because
time.
I'm not imposing an exogenous value on it. I'm letting the model determine the value of the Leon variable. And if it is 0, this means that my model is correct. Is
Okay,
this clear?
Clear, yes, yes.
Can I ask something?
Yes.
The maximizing of any function just to differentiate it and equate the differentiation with 0. Differentiate it with respect to each variable and equating each equation by 0. Just like that, not y equals 0. The change in y equals 0.
No, not the change, neither the change nor the level. What I was saying in the first part of GUMS, I mean that there are 2 different things here. What I was saying is that is y minus c is equal to 0. Because y is equal to c. Is that clear?
Yes, but I mean the first equation, I differentiate it with a, with respect to a, and with respect to k, and with respect to l, right?
No, just with respect to k and to l.
Okay. Okay.
And then I equate that to 0 to maximize my marginal productivity.
that means that the change in is the change of y with respect to k equals 0. That's what I mean.
Yes, exactly, because that's the first order condition.
Yes. Okay.
Yes, I didn't hear in the beginning, so that's why I thought you're talking about this equation where we sorry. So where we have the y that is equal to c, and when GUMS will solve it, it will be written as that. But I mean, your question is that we have to take the partial derivation of y with respect, the partial differentiation with respect to k that is equal to 0. And we do the same for wages, for labor, sorry. So those are the two first order conditions. Is that clear?
Yeah. Yeah. Yes.
Okay, other questions?
May I add something?
Yes.
I think the Lionel, the extra variable we add,
Yes.
plays as the language multiplier. Its
In
value,
which sense?
its value is 0, and it plays the role of making the maximization, for example, or the optimization.
Not the optimization, it's the whole model actually.
The whole model, yeah.
Yes, the whole model, not just the optimization of a specific equation, because it's the
Right.
variable that guarantees that the whole system is in equilibrium.
Is in equilibrium, yes, yes.
Yes. Other questions? Okay, so if we don't have more questions, we will have the break now, and we will start right after the break coding the model. So we will write in GUMS this model. Please make sure that your GUMS is working. After the break, we will mainly work on GUMS only, and we will see how to code the model, how to run the simulation, how to extract the results, and how to analyze them. So now it's 5:20 in I mean Cairo time. We will break for 15 minutes and we start at 5:35. Okay?
Thank you.
Have a nice break and see you in a while.
Thank you.
Any questions on what we've done so far? Okay, so let's now start the GUMS code. I will show you the code. So you will have now to start your own GUMS. So to start your own GUMS, I will share the screen in just a second. Okay. So now when you press on GUMS, you will have this screen. Okay. So that's what we get in general. IDE or Studio. I mean, personally, I prefer IDE, not Studio. But if you downloaded Studio, we will be able to use it as well. Then, in order to start our code, we have first to create file. So we press on File, Project, and we press on New Project. Okay. And we can call this new project, for instance, GUMS workshop. This will be our directory or the folder in which everything will be included. Okay. And we create the folder. Then within this folder, we want to start the GUMS code. And for the GUMS code, we start File, New. We will have a blank file like this one. Okay. So we can save as, just to, we call it, for instance, basic, because that's the first model that we have. So we call this, we call this file basic. Okay. Now we will start writing the code itself. So as I said, the first thing that we have is to insert a title for our model. So for instance, I will write basic model. Okay. And I can add a note. You can see my screen, right? Do you see the screen?
Yes.
Okay. So I will add a note where I write basic model with one factor, with one good or one sector, two factors of production, okay. Closed economy without government. And I will add a second note, for instance, TRF training workshop, October 2021. So as you can see, these two lines are deactivated. So they will not be read by GUMS as a command. Okay. Dalia, would you please mute your mic? Any questions on that so far? Okay, so now I remind you that what we want to ideally do is to run the model, get the results, and interpret the results through or using the same code that I presented in the beginning. So to start, the first thing, we have to declare the variables that we have in the model. So we will write the word variables, and as you can see, it becomes blue. The variables that we have, if you remember, we had 11 variables. So we have Y, that is production. We have L, that is labor. We have K, or I will use LD and KD to distinguish labor supply from labor demand and capital supply from capital demand. So here labor demand, then the KD will be capital demand. Then C represents consumption. P represents prices of goods. Then W represents wages. R represents rents. LS represents labor supply. KS represents capital supply. Rev represents revenue. Anything missing? So 3, 4, 5, 6, 7, 8, 9, 10. And the final variable, Leon, which is the Walras law. So that's the list of my variables. Any questions on that? So two things. First, what I did here, I declared the variable, right? Y, L, D, K, D, C, etc. before using them. And we said that this is a very important rule in GUMS because I cannot use a variable unless I declared it. Okay? After this, we need to declare the parameters. So I will write parameter. Okay, it becomes blue as well. And the parameters are of two types. So the first type of parameter are the parameters included in the model, which are A and alpha. So what does A represent? It represents the technology parameter. And alpha represents the elasticity of capital. Right? But adding to this, we have also some parameters. Okay? So in this case, the other parameters are all the variables that I have here. I will take them as copy and paste. But I will add a letter O to all these variables. And I will explain immediately why I'm doing that. So what I did, I took the same list of variables and added O to all these variables. Okay? Why I did that? Because all the variables that I have in the base year are constant because they are the variables of the base year. And that's why we can consider them as parameters. So in order to declare that the variables of the base year are parameters, we add an O to each variable, as you can see here. I didn't include the Leon because the Leon is not in the base year. It's like a verification variable only. So it's not really a variable that is included in the social accounting matrix in the base year. So that's why at the end, I want to have YO, LDO, CO, PO, WO, RO, LSO, KSO, and REVO are the same variables that I have here, but to which I add the O and declare them as parameters of the base year. Is that clear?
Yes, doctor, it's clear, but I have another question.
Yes.
I'm sorry. I thought when you explained in the beginning that when that writing, when the software itself writes things in blue, then it understood that these are variables and these are parameters and so on, right?
Yes.
Okay. I'm using GAMS Studio, unfortunately, and when I write $sign title basic model, he wrote basic model in blue. So it means that
no,
it got.
I mean, it doesn't matter because as you can see here, when I write, for instance, variables, Y, production, labor demand, all this in my case, it's also blue, right?
Yes.
And if they are, excuse me, just a second. أيوة. طيب 5 دقايق وهاجي. So as you can see here, the production, labor demand, capital demand, consumption, all these labels are in blue, right?
Yes.
So all these labels, they do not matter for the GAMS code, because what will matter for GAMS code is just the variable declaration here, the Y, the L, KD, etc. But for the blue part here, it's just for me to clarify what is the meaning of this of each variable. So sometimes in some cases we have some blue labels, but this does not mean that it's a command like variables here or parameters. It's just a light blue for clarification, not for running a command.
Okay, thank you, Doctor. Okay. Thank you.
I have a question.
Yes.
Perfect. So one question and one comment. Just to reply to Nadine, I think that she left a space before the $sign in title. If she removes the space, probably model will become black. And my question is related to the previous one. Can we, for example, import the variables from an Excel or CSV file? So, for example, declare variables, and then in the second line, say import this list as variables, because it's quite handy when we're having, for example, hundreds of variables to treat them in CSV or Excel.
In general, for the GAMS code itself, I mean, I'm doing the basic one because really we want to go into the details of coding. That's one. Two, in some cases, I mean, if you declare the variables that we have here, if you remember, I added the letter O to all the variables just with the same list, right? We have in GAMS some commands where I will have in one file all, I mean the list of all the variables that are included, the 100 variables that are included in my model, okay? And then I can tell GAMS to add, for instance, the suffix O for parameters and the suffix, for instance, GR for the growth rate and so on. So in general, there are some other easier commands that can save some time, but currently we're working on the basic version just to understand the rationale behind the code itself. Adding to this, what we import in general from Excel is the data, but for the code itself, it has to be declared within GAMS itself in a GMS file, because GAMS reads in general the CSV or the Excel files to import the data, but for the code of the model, it has to be in a GMS file. Is the difference between both clear? Abdullah? Did I answer your question?
No. Everything is clear. Speak, Salah, do you have anything else to say?
No.
Yeah. No, everything is clear. Thank you.
Okay. So that's for the variables and the parameters of the model. Now what we'll do, you will have 20 minutes using the rules I presented before the break. You will write the GAMS code. I will just write one example to show you how we do it, and then you will do the rest on your own, and then we're going to correct them together. So we have first the production function. that's its name, and then to give it to assign to this equation a value, we write supply. It will be y that is equal to e that is equal to, sorry, here we have to write equations, right? And then y that is equal to e equal to a star L to the power 1 minus alpha. So that's the Cobb-Douglas production function multiplied by k to the power alpha. And then I add a semicolon at the end. Okay? So you will have to do this for the 8 equations. You have, I remind you that you have to declare all the equations first, and then after this, you assign a mathematical value for each equation. So now it's 5:56. You have until 5:10 to list the equations and write their mathematical statement. And then we will have, I mean, some of you will share their screen in order to correct all the codes and see how we'll proceed later with the next steps with the calibration, the initialization, and running the simulation. Okay? So we start now. I will present. Now you can see the list of equations, right?
No, we cannot see the equations. We cannot see the slides.
Just a second. I will reshare again. So that's the list of equations. So now please write the 8 equations, and don't forget to add the Léon variable to one of the equilibrium equations. And the Léon variable is will be added either to the consumption, to the equilibrium of goods, or the equilibrium of labor market, or the equilibrium of the capital market. Okay?
Doctor, can you please show us the example again, because I didn't have time to.
So that's the example. So I will send you the example in the chat box, and share the model itself, the mathematical statement of the model. Okay.
Okay. Thank you, Doctor.
Okay, let's start. So you finished? I will
Not
stop
really.
sharing.
Not
Sorry?
really. Not really. Just a few seconds.
Okay.
Zahid, can you please check the chat box for my questions in the meanwhile?
Why does supply have blue color only? No, why? It's black.
Can I share my screen just to show you what's the problem or why?
Okay, just a second. Yes, please share your screen.
Here.
Yes, I will come back to that because there are some errors here.
Ah, okay.
Okay.
Okay, because I copied paste also in the chat box.
There are some errors, but I will come back to that.
Okay, thank you. Because the other variables also should have the blue color, right?
Yes.
Okay.
But there is an error, so I will explain.
Okay. Okay, thanks.
Dr. Shahir, can I ask something until the rest finish their equation?
Yes, sure.
I'm not sure if I can, okay, in Studio I could open a new file, but because I have a bad internet connection, I didn't see how you created a new project. Does it differ if we just created the file or we created a project on GAN?
I mean, in general, for the time being, the difference between the project and the file is not important because we will have everything in the same. We will have everything in the same, I would say, file. Okay, but the importance of the projects come from the fact when you write your code in different files and you want to have everything within the same folder. So in that case, we need to create the project before the GMS file. So do you understand? I mean, in other words, if we have our code written in several GMS files, to let GUMS understand that everything is related to the same model, they have to be in the same project. But if I'm writing everything in just one GMS file, it will not really affect my coding.
So can you tell me at the end, yes, how to create?
Yeah, I mean, I can show you now. So you just you press on File, Project, then New Project, and if you press on New Project, you will get a box asking you to write the name of the project. And then the project will be generated. You can call it, for instance, basic, simple, anything, workshop of GUMS. I mean, any name that you want. And then within the project, you will just press on, again, File, New, and this will generate the blank file where you will write all the code.
The problem is that I think the interface for Studio is different. When it first opens, it just gives some options to create new file, but not to create a new project. And the interface from the beginning is different from the one you showed us.
Yes,
so I think I have to look for it.
No, but because you have, I mean, did you press on project, not on file?
From the first beginning, I didn't see anything about project. It was just file. So I pressed on file just to start with you, not to be.
So in this case, you have to close the file.
And then open the okay.
And start from the beginning a new project that includes the file, that includes a new file that you will generate, I mean. Or perhaps if you want to share your screen, and then I will be able perhaps to better explain.
Yes, I can share I don't know. I would see how I share my screen, but just one second.
There is share screen icon in the middle below.
This green button.
Share screen is written green.
I can't find it. I don't know why, but I can't find it. I just find question and answers record. Oh yes, share screen. The only green button down. I'm sorry. Thank you. Thank you for your help. This is my screen. It should be like. So this is can you see my screen, Dr. Chahir?
Yes, I can, but I'm not really familiar with the Apple interface. This is an Apple interface, right?
Yes. Yes.
Yes. Please. It's a bit different. Perhaps it's definitely not the first icon, neither the second nor the third. Perhaps click on this the 1, 2, 3, 4, 5, the sixth icon. Yes.
This
yes,
one?
exactly. We get nothing.
Yes.
Okay. So in any case, let's start writing the model, and then we can check this later.
Actually, I use the second icon.
This one?
Yep.
No, this one is to open a file, not a project.
You know, it's, you can open it like a new folder. It's gonna make it a new file for you. Anyway, it's okay.
Yeah, but it's not a file. She needs a project, not a file. Do you see?
Yeah,
the GPR, not the GMS. So click again on this. Okay.
I thought you're going to start the session. I didn't want to spend.
I mean, click on this. Open again.
This?
Yes.
Okay.
No, close this window. Open. Perhaps click on the one beside this. Yes. Save as new. This drop down menu. Click on it.
This one.
Yes. No. We don't have the GPR here. Okay, so let's see this later because we have to search how we can do it on Apple. I'm not familiar with that, and I don't want to say something I'm not sure of. So let's move to the GUMS code. So who would like to share his or her screen to discuss the code? So Ibrahim, would you share your screen?
Unfortunately, the battery of my laptop running out. Would anyone else share his screen, please?
I'm ready.
Alauddin, would you share yours?
Yes, of course.
Okay, please do.
I have some problems, so.
Yeah, no worries. I mean, that's the idea.
Yeah.
So title, basic model. Okay, basic model. Okay, ERF training variables, Y, LD, KD, C, PLS, KS. I mean, a very minor comment, but then it becomes very important when we start working on real models.
Okay.
Is to have the GUMS code as clear as possible. What does this mean? It means that it's in general, it's better to align everything.
Okay.
Meaning like what I did in my file. So production, labor demand, capital demand, consumption prices of the good, labor supply, capital supply, revenue, Walras law. Everything has to be aligned to make everything more reader friendly when you start working on the code.
Okay.
And the parameters, okay, that's fine. Equations. So what is the problem here? The first thing, so let's go through the equations first, and then we we see what's missing. So the first equation, supply 2 dots, okay, alpha L1 minus alpha, that's correct. Wage, what is incorrect here in the wage equation? What do you think?
We need a semicolon after wages.
It's already here.
Oh.
I think E is capital equals capital.
No, in general, GAMS is not case sensitive, so this will not affect the result.
Okay.
I think the name of the wage one is not there.
No.
Equation is with S.
Sorry?
Equation is with S. No?
The equation, sorry, is?
Plural.
With S.
That doesn't matter.
No, it's not that. No, it's not that. In the wage, I'm talking about the wage equation.
I think it should be multiplied with labor.
Yes, the wage and the labor demand should be
exactly. So we need the multiplication after the W and after the R. Exactly.
And
that's
I
one
think
thing.
May I have a question?
Yes.
In the variables, we define labor demand as LD and in capital demand as KD. And
exactly. No. Just one second. So that's the second error, because here the L and the K have to be declared as labor demand and capital demand.
Yes.
So you have to change the L with an LD and the K with KD.
Yeah.
Okay. So now we have W multiplied by LD, which is equal to E, 1 minus alpha multiplied by P by Y, R KD, alpha by P by Y, okay. Revenue, W multiplied by LS plus R KS, that's
Can
fine.
I put them in brackets?
It will not affect.
All right.
I mean, mathematically, it's you can keep them or remove them. Because in any way, I mean, we'll have the summation that is stronger.
Right.
And also Leon.
Sorry?
There is no Leon variable here.
Yeah, we're coming. I mean, we're going through each equation. So then PC is equal to E equal revenue, Y equal to E equal to C, LD equal E equal LS. Okay, and the last one. And as Shabnam said, we have to add the Leon variable, and the Leon variable has to be added to one of the equilibrium equations. So you can add it to, we will not call it income because it's not income. We will call it the good equilibrium. So you can call it, for instance, good EC. Okay. And labor, also change it to labor EC to show that that's the labor equilibrium and capital EC. Now the equations are correctly identified. What is missing in this code?
I'm not sure.
Dr. Chahir, if I can, I'm a little bit confused here. Because in the example you gave, you declared supply first and then supply with the dots and the equation.
Exactly. So we have before equations, we have to list the name of the 8 equations. So in other words, after the word equations, start writing supply, new line, wage, new line.
New line like this.
No, without the slash. Exactly. Supply, then enter, new line. No, without comma.
Without, yeah.
Okay. Okay. Supply, wages or wage. The most important thing is that they have to be
the same as
name.
I, yeah.
Exactly. And after you list the 8 equations, you add a semicolon.
Okay.
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 So now you can stop sharing your screen and we can take another example, perhaps who would like to share.
I just want to understand this.
Thank you so much.
Before we move on. I don't understand why we declare this equation. Does it like an object where we allocate the formula into, so we can call it later?
I cannot hear you very well.
Can you hear me now?
Would you please repeat again?
So I just said, what is the reason why we declare this equation like this? Are there like an object where we allocate the equation, the formula into, so we can call it later for other purposes?
if you remember, one of the rules, I mean, in GUMS is to that we have to declare first and then use. I cannot use before declaring. So before using those equations, or before using the variables, or before using the parameters, I have to declare what is this thing that I will use in GUMS later. So that's why, given the fact that I will assign later to each variable, sorry, to each equation a mathematical statement, then in this case, we have to tell GUMS what does the equation, sorry, what is the name of the equation first, and later, so what is the name of the equation first, and later, what does the equation look like? So that's why we have to list the names first, and after that, we assign to each name, supply, labor demand, capital demand, labor equilibrium, and so on, a mathematical value. And this approach has to be adopted everywhere across GUMS. I cannot use anything or present a mathematical statement before declaring what does this variable or what does this equation mean. So is that clear?
So later, if I'm going to use this equation, this formula, this function, for instance, I just call the object and make use of it in another formula. I combine it in another
you will not use it later, because the only stance where you will write the mathematical statement of the equations and their values is in this part of GUMS. What will be used later in different stances is the variables, because you will need the variables to recall them again in order to generate the growth rates, for instance, of the simulation with respect to the benchmark scenario. You will recall the parameters in the calibration, but the equations, they will not be used again. But you cannot declare the mathematical statement of the equations before declaring the equation themselves.
I see. And one last comment. I mean, the equations, when we miss the S, it doesn't matter here, like it is.
No, I mean both. It will both. Sorry, it will work both ways.
Oh, okay, d'accord. Okay.
Like that.
Okay, thank you.
Okay. Well, who would like to share his screen to have a second example before we move to the next stage?
Okay, I can share my.
Okay, please. So first, in the equations, we have to remove those asterisk or those stars because currently they are deactivated.
Here?
Yes.
Okay.
Everywhere. And then for the equation names, they have to be just one word. We cannot have labor space demand. It has to be, for instance, labor demand one word, or lab demand, or L demand, but it has to be one word.
Okay, you can make it like this.
Yes, but I mean in the listing, when you list the equations and in the equation themselves.
Okay.
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 So you have to have the same labels. Okay.
I'll make sure for that.
So that, and then after the list, after you correct this, you have to add a semicolon after the list of the equations, after the word revenue.
Okay, here? Or
yes.
The line?
No, yes, exactly. But better, I mean, it will change nothing, but better to have the semicolon in a new line, exactly, just to have the end of this section. Then for the equations, what do you think? So let's do a tour de table as well. So perhaps Nadine can start. In the first equation, what is the error?
Here.
In this equation, what's the error?
Yes. Do we have any errors in this equation?
I think no.
Exactly, it's fine.
In
Nasser
the second
al-Din.
equation, we have errors.
Yes, Nasser al-Din, the second equation, what do you think?
Okay.
I think he has to declare the variable and add the equal with the capital E, the equal.
So LD, which is the labor demand.
E, not Y. Labor demand equal.
Exactly. What is missing in the labor demand?
To declare the variables, the wage.
No, it's they are declared. It's not a problem of declaration. What's missing in the equation itself? In the labor demand equation.
Wage.
Wages, exactly. So you have to multiply W by LD. So multiply W multiplied by LD.
Just before LD, W.
Exactly, before or after. Yes, multiplied.
Multiply. W, okay.
Okay. Uznurat Zamar, what do you think? The following equation? Capital demand.
Again, R missing at the beginning in the left-hand side. He has to write R asterisk capital K.
Yes.
Equals.
So no, it has to be first capital demand, not K, not K.
Yeah, capital. No, R. It should be rent. Sorry.
Yes, KD multiplied by R.
Yeah, R multiplied by K.
Like that?
Yeah, I think Zahir. Do you hear me?
KD. So you forgot the D after the K.
Yeah, KD. Yeah, KD multiplied by R.
Exactly.
So
yes,
sorry, in the first supply.
Demand.
Sorry, in the first supply equation, the L
like
should
that?
be LD, no?
CD or KD?
No, KD.
KD.
Okay.
Sorry, I'm asking another question. In the first supply equation, the L should be LD, right?
Exactly. It has to be LD and KD.
Yeah, because it's L alone again. Yeah.
Exactly.
Okay.
A and KD here.
Yes. Okay. Abdulillah, the next one. Abdulillah. Okay. Karim.
Yeah, I think just need
It says I
add,
can't share if someone is sharing.
Yeah, I think you need to add plus lion and after Y.
Okay, so first.
He gonna start with. Yeah, it's okay.
Yeah, please go ahead.
Yeah, we can say that, or we can. He can add it anywhere. If you consider add it in different places, so I believe this one is okay.
Exactly. So this one is correct as long as Leon is added elsewhere.
Yes, correct.
Nisma?
Can you hear me?
Yes, we can.
Yeah, I tried to share, but it says you cannot share.
No, I was not asking you to share your screen. I was asking you to comment on one of the equations.
Oh. Okay.
So on prices, do we have anything that is incorrect?
I just saw I didn't put prices in my equation.
Sorry?
No, I just realized I didn't put prices in my equation. But
no, actually, the correct name of this equation is not prices, it's demand, because it's the demand for goods.
Demand?
Yes. So mathematically, it's correct. But then for wages and rent.
Changes. It's here.
Yes, exactly. For wages and rent, they are redundant with respect to what? To labor D and capital D, because they are exactly the same thing. So you can delete them.
KD?
No, you can delete these two lines because they are identical to the labor demand and capital demand that you have after the production.
So you have to remove LD.
You have to completely delete these two lines, wages and rent. Delete them, yes. And then for labor supply and capital supply, they have to be equal to labor demand and capital demand. So LS,
okay.
LS equal E equal LD.
LS equal E
equal LD.
Okay.
And remove the rest. The same thing for capital, KS equal E equal KD. Remove the rest, but keep the Leon. Keep the Leon. Plus, not minus.
Sorry.
And then for the revenue, it's correct. Okay?
Okay, thank you.
Okay. So just to try to finish, I mean, at least this model today, I will now send you in the chat box the correct version of the first part, so that you can so that we can build on it and continue the model. Okay. So I will send you this right now.
Doctor, can I ask questions?
Yes, sure.
For the order of equations, is it necessary to order the equation?
No, it doesn't matter, but in general, I mean, in theory, it doesn't matter. It will not affect the model resolution. But in practice, it's better to put similar equations together, meaning that it's better to have equations that deal with the equilibrium together, and put the equations that deal with demand together, and so on.
If the wage equations equals, for example, LD, for example, LD plus blah, blah, blah. So I must define the LD at first, LD equation at first.
You have to demand, you have to define the equation and the variables, both.
No, I must write the equation of LD at first, before widget, for example.
Before, sorry?
If W equal LD plus K, for example. W equal KD plus LD plus KD, okay? That's just an example. Is it necessary to write LD equation and KD equation before?
No. The order of equation doesn't matter. But what matters is the order of variables. I cannot use a variable in the model without declaring the variable before.
Okay.
So this holds for the variables, but not for the parameters, but not for the equation, sorry. So I will send you in the chat box the code. That you will copy and paste in your I don't know why it's not working. Well, perhaps yes. So that's the first part of the variables. And then please copy and paste them in your code. Then the parameters. Then the equations with their names. And finally, the mathematical value of the equations. So now you have 4 parts, correct? Any questions on what I have sent?
Yes, please, Shahir. Equations will be in black, not yellow. Sorry, blue.
The word itself, equation in blue, but
In
the
blue.
equations in black.
At the rest, yeah, at black. Yeah, okay.
Yes.
Thank you.
So now we are all on the same page.
Because you shared your version, maybe someone else put LD instead of L because your labor demand is only L. So if someone wants to copy paste, they have to make sure that the variables up are the same. Am I correct?
Yeah, but I mean, what I sent you, you have to copy and paste it everywhere. I mean, just because we will build on that. So that's why even if you used it before as LD, it's better to change it to L just to let all of us be on the same page.
Got it. Thank you.
No, I didn't share. I sent it in the chat box. So did all of you copy what I sent in the chat box in the GUMS code with disorder,
Yes.
variables, parameters,
Yes.
equations, and the mathematical statement of the equations? Okay. Now we have to move to the calibration. So what is the idea of calibration? The idea of calibration means that we want to determine the value of the parameters that we have in the model. And if you remember, we had two types of parameters. We had the parameters that are the variables with the word O, right? And it's O not zero, make sure. And we had the parameters that are A and alpha. So do A and alpha exist in the SAM?
No.
No, they don't exist in the SAM, exactly, because what we have in the SAM is value added, consumption, production, savings, and so on. So this means that what we want to do is to calculate the value of A and alpha from what we have in the SAM. I remind you that the production function is y is equal to A K alpha L 1 minus alpha. Okay? So I can say that the A So I can say that the A is equal to y over K alpha L1 minus alpha, correct? So that's this means that if I want to calibrate the A, I can write it this way. But the problem is that in order to calibrate the A, I need what else? I have the Y, I have the
We
L.
need alpha.
Alpha.
Exactly, I need alpha, and I have the K in the SAM. So we need the alpha. This means that now we want to calibrate the alpha. If you remember from the maximization problem that we did, partial Y with respect to partial K is equal to alpha A K alpha L 1 minus alpha, and here we have minus 1. So, and this we said that it will be to the real rent, which is R over P. So I can write it again that it's alpha A K alpha L1 minus alpha divided by K, which is equal to R over P. So I can say that all this term is equal to Y. So in this case, it will be alpha Y divided by K, which is equal to R over P. So I can say that the alpha is equal to R multiplied by K divided by Y P. And that's the way we calibrate the alpha. Why we can calibrate alpha this way? Because in the SAM, if you remember, we said that we have values, which means that we have the value of our that they are values, right? And R multiplied by K is the value of capital remuneration, and Y multiplied by P is the value of production. So this means that at the end of the day, alpha represents the share of capital remuneration in total value added. And the numerator and the denominator, I have them in the SAM. So that's why I can first calibrate the alpha. And once I calibrate the alpha, I can calibrate the A. So that's what we call the process of calibration. Is that clear? Any questions?
Crystal clear.
Thank you. Any questions on the calibration?
I want to ask, because I'm confused, it's alpha equal R K or KO?
No, R multiplied by K, okay?
K only, not KO.
You know, I will come to that later, but for the time being, the formula that we used is that alpha is the share of the capital remuneration over the value of production, okay?
Okay, but I want to calculate K or estimate K for.
Yeah, I mean, is this formula clear?
Yeah, it's clear.
Okay, that's my question. Let's move to the next part. So, given that we derived the formula of each parameter on its own, we want now to calculate their values from the SAM. Okay? Can you send the equations over again? You mean the equations of the model? Hussein Eddin, you mean the equations of the model? Okay, I will just finish this and send them again. So we will now what we want to do is to calibrate from the SAM the values of these parameters. So in order to calibrate the values of these parameters, we have to use this data coming from the SAM. And from what I said in the beginning, the data in the SAM, given the fact that that's the data of my base year, I can say that I will calibrate those parameters from the data, and the data of the base year has been declared with the O with the O after each letter. Because if you remember, we declared that all the parameters that we have, that all the variables of the base year have been declared as parameters, and if they have been declared as parameters, we added an O to these variables. And given the fact that I want to calibrate my parameters based on the values from the SAM, so I will use the variables but with the O version. So it will be YO, KO, LO. Here it will be RO, KO, PO, and YO. Why I'm calibrating from the SAM? Because that's the data that I have in the base year. And that's why I have to do that from the social accounting matrix by using the variables with the O version. Okay? So this means that, and that's the final thing we'll do today, we have to calibrate the variables from the SAM, which means that I have to declare first the variables of the SAM, because if you remember, we said that I cannot use anything in GUMS unless I declare it first. So I have to declare the value of R, I have to declare the value of K, I have to declare the value of P, to declare the value of Y, and to declare the value of L. All this has to be declared first. We said also in our analysis that all the prices of the base year will be normalized to 1, which means that the price of base year, PO, can be equal to 1. My wage and my rent of this model can also be equal to 1. Why? Because we said that all prices of the base year will be normalized. So the first thing that we write now in the code after the part that you wrote is I will just take that. So now you can see the GUMS code.
No.
Okay, just a second.
No.
I will share it.
We see your face.
No, I will. GUMS is better, so I will share GUMS now. So now we'll declare RO, which is the rent of the base year, which is equal to 1. Then WO, that is equal to 1. And PO, that is equal to 1. So we did that because, as I said, we normalized the prices to 1. And the stage is the calibration. So I can write a star here and say calibration. Okay, and here we have the calibration, the first part of the calibration, or what I will use later, I mean. I still need the value of LO and the value of KO. Okay? The value of LO and the value of KO will come from where? In theory?
From SAM?
From the SAM, exactly. So if they come from the SAM, we assume that K is equal to 4. That's just as we're working with a fictitious economy. So we assume that LO is equal to 6 and KO is equal to 4 because those are the values that come from the SAM. Okay? And then we can say that YO, which is my production, and we know that the production, the definition of GDP is the sum of value added. So it can be equal to LO plus KO. Correct? The important thing now, LO and KO. LO and KO are in values or in quantities. What do you think?
They are the quantities.
They are in
quantities.
No, because we said we agree that they come from the SAM, right?
They are
and what we have in the SAM is the value, not the quantity. Is that correct?
But we assume that all the prices are equal to 1 or normalized.
Perfect. Yes, I totally agree with you. But we assume this only when in the base year, right?
All right.
And later, the rent and the wage will change. So that's why the first thing I have to do is to convert the LO I have into a new LO that is a quantity. And the KO will become also a quantity. So for GUMS, what will GUMS understand? Because now it might be confusing for GUMS. I'm saying in the beginning that LO and KO are values, and then I'm asking GUMS to calculate a new L and a new K, where he divides LO by WO and divides KO by RO. So in fact, GUMS will keep in his memory the last command that was written, meaning that starting this line onward, GUMS will assume that labor is a quantity or a value?
Quantity.
Quantity, exactly. And that's why now the YO, which is equal to LO plus KO, now the YO is defined on an LO that is, it's a quantity, KO, it's a quantity. So YO will be quantity or a value?
Quantity.
Quantity, exactly. What happens if I put YO here? Is it a quantity or a value?
A value.
Exactly, because it comes after the two values. So that's why the order is really, really important, and it can lead to a lot of errors when we have more complicated models and when we run the simulations. Okay? Could we put the sum within the code? We don't have a sum, we just have some basic values that we use in order to run the simulation. So currently our sum is equal to 4 and 6. That's for the time being our sum. Okay? Let's now calibrate A and alpha, and that's the last thing that we do today. So for the calibration, the easiest thing is to take the formulas I have in the model. So I will take this formula that I have here of my production and I will put it here. What is my unknown? What is my unknown now?
Alpha and
A. So I will take the A, put it here, and say that it's equal to y divided by all that. Is that correct? Am I missing something?
No, it's correct.
I should put alpha first.
Exactly, I have to put alpha first because I cannot calibrate A without the alpha before. And the formula of the alpha, I can take it from here. Why I'm doing a copy and paste? To avoid any errors. Because in this case, I will have the formula as it is. So alpha is equal to R multiplied by K. I remove the E because it's not an equation. I'm calibrating now, and I have to write it this way. Correct? What I still have to add to those two terms in order to make them correct. We said that the calibration takes place based on what? Or using
the
what?
base year values, the base year values.
Exactly, the base year values. So I have here to add O's everywhere. O's and not zeros. Make sure that you're adding O and not 0. So I will send you this last part, which is the calibration. Okay. And I'm sending again the equations for those who want them. So for next week, we will continue the rest of the code and we will run a simulation. We'll analyze the simulation and see how we can extract the results in an Excel sheet. Any questions on what I have done today? Anything that's not clear?
Thank you, Chahir.
Okay, so if we don't have more questions, sorry?
Alpha here depends on quantities or values. Alpha
now includes quantities because everything, I mean, here, that's a very good question. If you remember here in the chat box for the alpha, it's equal to ROKO divided by POYO. If KO and YO were not declared as quantities, not values, I would have been a problem of double count. Why? Because this means that I'm multiplying a value by a price, meaning that I have the price twice. So that's why I have to make sure that this KO and the W and the YO both are quantities, not values. And that's why this has been done here. As I'm showing, I mean, it's shown in the chat box. So the LO is equal to LO divided by WO. The KO is equal to KO divided by RO. And this means that all the variables that will be, these variables that will be used later, they are quantities, not values.
Okay, thank you.
Doctor, I want to ask something. If we can just maybe next time can you show us how can you pick up these values from SAM? يعني how each of these variables correspond, or at least one of them, just to
Okay, I will start with that next week.
Okay, thank you so much.
Okay, so with that we'll stop here. Thank you all, and thank you for your active participation. We'll see you next Monday at 4 p.m. Cairo time, and we will send you all the material afterward. Thanks, and see you all next week.
Thank you.
Thank you.
Thank you.
Bye bye.
See you.
Thank you.
Yeah.
Bye.
Bye, thank you.